Okay, welcome class. This is lesson 15.2. Did I catch you by surprise? Are you awake now? This is lesson 15.2, two-way relative frequency tables. This is the last lesson of the pre-algebra textbook. Whoa, that's crazy. Now, as much as I want to say this is like a really easy thing and it's just going to be super easy to understand, it's actually quite complex. There's some vocab words that we're going to have to learn, and the second half of this lesson, it does get a bit challenging. So you have to be able to wade through this. Now, with that being said, you persevere, and also everything that we're talking about in this lesson, we actually already know basically the general idea, except now we're formalizing it. So we went through it previously, but now we're formalizing it. So what do I mean by that? Well, last lesson we were focused mostly on just two-way tables with numbers. But at the end, that last bit, we actually found the relative frequencies of each thing and put it into the cell. So instead of just numbers, we were putting percentages. And I did that in the last lesson video, 15.1. So go check that out first if you haven't seen this one for sure. That will be helpful. And now we're not going to be just thinking about the numbers, like numbers of dogs or cats or men or women or something. Now we're concerned with the relative frequencies. And so that's actually always going to be a percentage or a decimal because it's going to be some ratio of something over a total. Now, you have to be able to keep track and focus in on every single thing every step of the way because it builds onto itself. Each step of the way builds onto the one previous. So please, please, please take notes as you're watching this, or watch it all the way through and then go back and take notes. But focus in because there's some vocab and there's just important stuff that you got to get. So I hope you're focused. It's not crazy hard. It's not something you can't do. You definitely can do it. You simply need to apply your beautiful brain and you will have lots of success. So let's go. All right, two-way frequency tables. So here we're talking about how can categorical data be organized and analyzed. Now we're talking about really analyzing this data. So first we want to talk about creating a relative frequency table. So let me copy this whole thing in. We got dogs and cats. Excuse me. All right, so the frequency table below shows the results of a survey that Maria took at her school. She asked 50 randomly selected students whether they preferred dogs, cats, or other pets. So here's 50, 22 preferred dogs, 15 preferred cats, and 13 preferred other, maybe birds or lizards or something. Convert this table to a relative frequency table that uses decimals as well as one that uses percents. Okay, so here we have a regular two-way frequency table. Now we're going to create a relative two-way frequency table. A relative frequency table, except this isn't two ways, actually, it's just one way. So a relative frequency table that uses decimals as well as one that uses percents. So decimals and percent. That is a relative frequency table. That's what we're doing. This is regular. Now we're making relative with decimal or percents. So how do we do it? Well, there's only one total to divide over, so it's pretty obvious. If we want to find the relative frequency of people that like dogs over the total, we just do 22 over 50 and we get 44.44. Now, if we want to do the same thing for cats, we're going to do 15 over 50 and we get 30, 0.3. If we want to do other, we do 13 over 50, 13 over 50, and that's 0.26. And total, obviously, is 100%, or 1, okay? Now, if I want to change that to percentage, it's 30%, 26%, and 100%. Awesome. So there you go. The relative frequency of people that like dogs is 44%, people that like cats is 30%, and other is 26%. What does this mean in another way? Out of the 50 people that were surveyed, 44% like dogs, 30% like cats, and 26% like some other type of pet. Cool. Now you can see how this is actually more helpful than just this, right? Because even though I know the numbers, I might not know, oh, that's 44% or almost half, right? But this relative frequency table helps us to see the relative frequency of each specific thing. Think about that word, relative frequency. The frequency of something relative to what? Well, relative to the total. The frequency of people that prefer dogs relative to the total number of people surveyed. Cool, that's what our proportion is. 22, the number of people that like dogs, relative to the total, 50. That's relative frequency, okay? Side note, if I was just talking about frequency, not relative frequency, then I wouldn't have to have it relative to anything. I would just say, okay, out of the million people in, Broward County, what's the frequency of people that eat bananas every Tuesday? And it might be like 3,000 or 30,000 or maybe 300,000 people in Broward County. That would be the frequency of the people that eat bananas, okay? Or I might say in something that might make more sense, hey, how many times out of a week, or how many times out of a week does someone go to the gym? What's the frequency of your gym attendance? You might say, oh, it's 3 days. So 3 days out of the week, 3 days out of 7, or 3 days out of the week I go to the gym. So the frequency of my gym attendance is 3 days out of the week. Cool. That's just frequency. But relative frequency would then be like, okay, what's the relative frequency of going to the gym? It would be 3 over 7, which would be some percentage. And if I do the math, it would be, 3 over 7 is about 43%. So the relative frequency of me going to the gym is 43%. What does that mean? Out of the total number of weekdays, 43% of those days I go to the gym. That's relative frequency. Regular frequency is just, oh, I go 3 days. You see? You see the difference there? Okay, so we're talking about relative frequency, the frequency of something related to something else. In this case, it's very simple. It's the frequency of dog, cat, or other people relative to the total number of people surveyed. Relative frequency. Cool. That's what we're creating. It gives us a good way of visualizing data. All right. Now, how can you check that you've correctly converted frequencies to relative frequencies? You add them up, and it should end up being 100%. Explain why the number in the total column of relative frequency table is always 1 or 100%. Well, because the total relative to itself is always 100%. All right. Creating a two-way frequency table. Let's bring this in. In the previous Explore activity, we did dogs, cats. If you have two categorical variables who have been paired, you list the frequencies of the paired values in a two-way frequency table. So before, we just had a one-way frequency table, but now we are doing a two-way frequency table. Okay. So to start, find the total for each gender. So now we've got people that like dogs, cats, and other, but now it's broken down with girls and boys. So breaking it down with that new subgroup, we're breaking out that data into not just total, but girls and boys. Now we've got a two-way frequency table. So for each gender, we add the frequencies in the rows. So for girls, 10 like dogs, 19 like cat, 9 like cats, 3 like others, so that's a total of 22. For boys, 12 like dogs, 6 like cats, 10 like other, so that's a total of 28. Now, adding up our columns, so that means there's 22 girls in the survey and 28 boys. And if I add those, 22 plus 28, I get my total from the last one, which is 50. Dogs, 10 plus 12, 22 people like dogs, 9 plus 6, 15 people like cats, 3 plus 10, 13 people like other. There you go. So now, if you remember, I have the exact same data as I had before, right? 22 cat, dog, 15 cat, and 13 other. Except now, so 22, 15, and 13. Except now I've got it broken down with girls and boys as well. Okay, and the grand total is, of course, 50. 22 plus 15 is 37, plus 13 is 50. Awesome. Okay, so reflect. Where have you seen the numbers? I just said that. In terms of Maria's survey, what does the grand total represent? The number of people that were surveyed. Awesome. Now, creating a two-way relative frequency table. Now, what we're going to do now is we're going to create a two-way relative frequency table for Maria's data. But before we do that, okay, and sorry, how we're going to do that is we're going to divide everything by the total. You see, divided by 50, divided by 50, divided by 50. That's a regular relative frequency table. But before we do that, let's talk about vocab. A joint relative frequency is found by dividing a frequency that is not in the total row or total column by the grand total. So anything in here is joint relative frequency. Marginal relative frequency is found by dividing a row total or a column total by the grand total. So let me actually go ahead and write that in. Let me show that to you visually. Okay, so if I have this, everything that I'm putting in blue, this is all joint relative frequency. Everything that I'm putting in red, this is marginal. Marginal. Okay, so blue is joint, red is marginal. You've got to memorize that. You've got to remember that. That's going to be on the test, okay? So anything that's just a regular piece of data, girls that like dogs, girls that like other pets, boys that like cats, that is joint relative frequency when you divide that number by the total. That's joint relative frequency. But if you take a total, like total number of people that like dogs, and divide that by the grand total, okay, this is grand total here. If you take the total number of people that like dogs or cats or other and divide it by the grand total, that's marginal relative frequency. And the same is true for the gender. If you take the total number of girls over the grand total or total number of boys over the grand total, that's marginal relative frequency. So if I asked you, hey, what's the relative frequency of the girls in this survey? That would be marginal because I'm talking about the total number of girls. If I ask you, what's the relative frequency of boys that like cats in the survey? That would be joint because I'm talking about something here, boys that like cats, that's an intersection. If it's an intersection, it's joint. If it's a total, it's marginal. And obviously the grand total is just the grand total. Okay, cool. Awesome. So just 1 second. I have to pause the video. I will be right back. Okay, I'm back. So where were we? We were talking about joint here, marginal here, grand total. Awesome. Now let's go ahead and create this two-way relative frequency table. We see a two-way relative frequency table displays both joint relative frequencies and marginal relative frequencies. And what you're going to find, is that in finding the joint and the marginal, you actually just do the exact same thing. It's just a little different way of thinking about it. So let's go ahead and create our two-way frequency table using our previous information. So here we go. All right. So what we have to use this information to create our relative frequency table. Now the first thing that we know in a simple joint relative frequency table where we're creating a relative frequency table where we're using just joint and marginal relative frequencies is that all of them are going to just be divided by 50. So we can save ourselves a little bit of thought by just saying, okay, everything is over 50, which is our grand total. In this simple relative frequency table, we're just dividing everything by the grand total. Let me make that in red to keep it consistent. Awesome. Okay, now that we have that, we can just take all these numbers and put them over 50. So this is 9, this is 3, this is 12, this is 6, and this is 10. And then we have 15, 13, 22, and 28. Awesome. So it's literally that simple. And then we just do the division. This is 0.18. This is 0.06. This is 0.24. This is 0.12. This is 0.2. So those are all my joint relative frequencies, and now my marginal. This is 0.3, this is 0.26, this is 0.44, and this is 0.56. And if any of you are wondering how I'm doing that division so fast, I'm actually not dividing. I'm just multiplying the number by 2 and then dividing that by 100, so like moving the decimal place over. So like 9 times 2 is 18. Move the decimal place over twice because I'm dividing by 100, that's 0.18. 6 times 2 is 12, move it twice, it's 0.12. 3 times 2 is 6, move it over 2, it's 0.06. So just a trick of dividing by 50. Cool, and that's it. We've created our relative frequency table, and there you go. And so this shows us like, okay, 30% of the people like cats, 26% like other, 6% of the people are girls that like other, 20% of the people are girls that like dogs, 12% of the people are boys that like cats, 44% of the people are girls, 56% of the people are boys. We see all of this in just this table. Okay, and that's the benefit of actually creating the relative frequency table, is we get those percentages rather than the raw data. Okay, and there you go. So that's the relative frequency table. Awesome. And then if you add them all up, you'll get that they're all the same. Cool. A joint relative frequency in it. All right, so let's reflect. A joint relative frequency in a two-way table, or you know what? Let me just not be, oh, I hit control new, so I can't bring that back. A joint relative frequency in a two-way relative frequency table tells you what portion of the entire data set falls into the intersection of a particular value of one variable and a particular value of the other variable. That's what I already just told you, just in a very wordy way. You can read that over like 10 times and you'll get it. What is the joint relative frequency of students surveyed who are boys and prefer cats as pets? Okay, so that was boys who prefer cats as pets. I don't have that, but that was whatever was in here. Okay, so you can rewind and get that. A marginal relative frequency in a two-way relative frequency table tells you what portion of the entire data set represents a particular value of just one of the variables. Okay, variables. This is a variable, gender. This is a variable, preferred pet. Okay, so a marginal is the proportion of the entire data set represents a particular value of just one of the variables. So one variable is gender. So a marginal relative frequency tells you the relative frequency of the value of just one variable, girl. So the value of one variable is gender. One variable is gender. The other variable is preferred pet. Marginal relative frequency shows you the frequency of the value of just one variable. So the frequency of the gender variable could be the frequency of girls. The frequency of preferred pet could be the frequency of cats. Okay, so that's what that's saying by the value of one variable. Whereas the joint relative frequency is the intersection of one variable and another. So the gender variable, girls or boys, intersects with the preferred pet variable, dog, cats, or others. And those intersection points, like boys who like cats, creates a joint relative frequency. And it makes sense. Joint is like together, two things that come together is joint. Like at a joint, like your elbow joint, this part of your arm comes together with this part of your arm, whatever. Joint, that's an intersection where margins, think about it like margins of a paper are at the edges, okay? What's the marginal relative frequency of students surveyed who were boys? And whatever was in here, that would be that marginal relative frequency that I already deleted, so oh well. Okay. Whew. That was a lot of words. All right, so what was the important thing? Joint relative frequency, marginal relative frequency, you just divide by the grand total, okay? Now, the next thing is conditional relative frequency. This is our next vocab word. And what is this? A conditional relative frequency is found by dividing a frequency that is not in the total row or the total column by the frequency's total row total, or column total. Okay, so what does this mean? Well, what this means is, oh gosh, it's using the same table again. So I'm gonna go ahead and create this table again because, yeah. All right, so conditional relative frequency. What is conditional relative frequency? Well, let me create this table one more time. So I'm looking at actual data. And so here we have 22, 15, 13, 22, 28, 38, and 50. Okay. Conditional relative frequency is something with a condition. So it's like, what's the relative frequency of people that like dogs given, and this is the key word here, given that they're a girl? If it says given, that points to you that whatever it says is given is the denominator of the fraction. So what does that mean? Like, I'm creating a fraction, right? It's something over something else, right? So in this case, if I say, what's the relative frequency of people that like dogs given that it's a girl? Well, if I know that it's a girl, I know that there are only 22 of them. 22 girls and 38 boys. So 22 girls, and then I have to look at, of the girls, how many like dogs? Well, that's 10. So my conditional relative frequency is something like this. Instead of dividing by the grand total, we divide by the thing that's given. It says given that it's a girl. Okay, so people that like dogs, 10, knowing that it's a girl. Okay, so since it's given that it's a girl, I'm not looking at the total number of people that like dogs, right? Because, yeah, 22 people in total like dogs, but of those people, 12 of them are boys, and I don't care about the boys right now. It says given that they're a girl, so I completely ignore all the boys. I'm just thinking about the girls. So given that it's a girl, I know there are 22 of them. How many of those, what's the relative frequency of the ones that like dogs? So it's 10 over 22, and so that would be what? 10 divided by 22 would be about 45%, or 0.45 repeating. This is conditional relative frequency. What's the difference here? The difference is the denominator. Conditional relative frequency is not over the grand total. It's over the total of a column or total of a row. So how do I figure out what the denominator is? It's this keyword given. Okay, let's say, what's the relative frequency or the conditional relative frequency that you're a boy given that you like cats? Given, keyword, cats. Cats is the denominator. But remember, I'm talking about boys, or I'm talking, now, in this case, I'm talking about cats. So what's my denominator going to be? The total number of people that like cats, which is 15. Now, the question is, what goes on the numerator? Well, what goes on the numerator is the intersection, okay? Boys that like cats is 6. I'm not interested in the total number of boys, that 38, because 38 over 15, that wouldn't make any sense. So the top is boys that like cats. That's what goes in the top. You see, here it was dogs, people that like dogs that are girls. That was here. The intersection of dogs and girls goes at the top. The intersection of boys and cats goes on the top here. Sounds like boots and cats and boots and cats, boys and cats. All right, people that like boys, boys that like cats goes here at the top. Okay, the intersection, boom. 6 over 15, that's the conditional relative frequency. And it's 40%. All right, so let me say this in a different way. Let's say I've got my survey, and I say to you, okay, of the people that like cats, what's the relative frequency that they're boys? What's the chances that it's a boy? So I say to you, okay, I've got this survey, and I'm only interested in people that like cats. So forget about everybody else. Of the people that like cats, what's the percentage of those that are boys? Okay, well, first I got to think, well, how many people like cats? There are 15. Well, of those 15 people, how many are boys? 6. Okay, so 6 over 15 is 40%. That's a conditional relative frequency. And what's the condition? The condition is that they like cats. I'm not interested in the amount of boys in total, like out over the total. like the percentage of boys in my survey. I'm interested in the percentage of boys with the condition that they like cats, okay? So that's why it's conditional relative frequency, because I'm not doing it over the grand total. I'm doing it with a specific condition, in this case, that they like cats. So given that they like cats means I'm only thinking about the people that like cats, that's 15. Now that I have those 15 people, how many of those are boys? 6. So what's the conditional relative frequency? 6 out of 15, 40%. What does that mean? Of the people that like cats, 40% are boys. And then this top one here, my condition is that they're a girl. So what's the relative frequency of people that like dogs given that it's a girl? Okay, so I'm given that it's a girl. So I'm forgetting about the boys right now. I know that it's a girl, so how many girls are there? There are 22. Well, what's the relative frequency of people that like dogs, given that it's a girl? Well, what that means is, of the girls in my survey, what's the percentage of those people that like dogs? Simple as that. Simple as that. Of the girls in my survey, what's the percentage of those that like dogs? So I take the girls in my survey, 22, and say, oh, 10 of those like dogs. So the conditional relative frequency is 10 over 22, or 45%. Okay, so 45% of the girls like dogs. That's what conditional relative frequency is. I'm not dividing over the grand total, I'm dividing over some condition. Okay, the condition here is girls, so I divide by the total number of girls. The condition here is cats, divide by the total number of cats. And then the numerator is just the intersection, right? Because I'm only interested in girls, and then I'm interested, of those girls, how many like dogs? Well, you can find that by the intersection of dogs and girls. Boom, 10 over 22. Here, my condition is cats, so I'm only interested in these people that like cats. And now I'm saying, which of those are boys? What percentage of those are boys? Well, to get that, I just find the intersection of boys and cats, which is 6. 6 over 15. Okay. I've said that now in about 7 different ways, so I hope that is clicked for you. Conditional relative frequency. In this case, I'm not dividing by the grand total, I'm dividing by a certain set condition. Okay, now joint and marginal relative frequency, remember joint is here and margin is here. Joint and marginal, I'm dividing by the grand total. Conditional is different, I'm dividing by a condition. Simple as that. Okay, awesome, thank you. Let's move on. All right. Oh, did I just delete something? I think so. Maybe I shouldn't have deleted that. Okay. So, okay, hold on. Okay. So now it says, find the conditional relative frequency that a student surveyed prefers cats, given that it's a girl. So cats, given that it's a girl. So remember, it's given that it's a girl, so my condition is girl, so I'm dividing by 22, bum, 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 bum. And then I'm looking at those girls that like cats, which is 9. So the conditional relative frequency is 9 over 22, or 40.9. Cool. Next, find the conditional relative frequency that a student surveyed is a girl, given that the student prefers cats. So now they flipped it. Now the condition is that they like cats. And then the relative frequency is, of those people that like cats, what's the percentage that are girls? So now my condition is cats, so that's 15. And then I have to find the percentage of those that are girls, which is 9. So it's 9 over 15, or 60%. You see how those are different? And that's because they're being compared to different conditions. Here, the condition is that it's a girl. Here, the condition is that they like, the condition is that they like cats. Sorry. Here the condition is they're a girl. Here the condition is that they like cats. Notice the number at top is the same because it's still the same intersection, but the condition is different. And how do I know what the condition is? In other words, how do I know what the denominator of the fraction is? I look at this word, given that the student is a girl. Given. Given that the student is a girl means I know that the student is a girl. Therefore, I'm only interested in girls. So I divide by the number of girls. That's my total in this case. Here, given that the student prefers cats, okay, I know that the student prefers cats as pets. Therefore, I'm only thinking about those students, which is 15 students in total prefer cats. That's the denominator. That's my total in this case, according to that condition. Okay. All right. Awesome. You can obtain conditional relative frequencies from a two-way relative frequency table. Find the conditional relative frequency that a student prefers cats as pets, given that the student is a girl. I think that we just did that, so I don't know. Okay, when calculating a conditional relative frequency, why do you divide by a row total or a column total, not by the grand total? That's the whole idea of conditional relative frequency. You divide by a total of a certain condition, not the grand total. All right, find possible associations between variables. You can use conditional relative frequency to see if there's an association between two variables. How? All right, Maria conducted a survey because she was interested in the question, does gender influence what type of pet people prefer? If there's no influence, then the distribution of gender within each subgroup of pet preference should roughly equal the distribution of gender within the whole group. Okay. Now, let's talk about this. Here, I've got my data. Now, if I want to figure out if there's an association between gender and pets, well, what I should see is the conditional relative frequencies should be the same regardless of the gender. So I should see that the conditional relative frequency of people that like dogs, given that they're a girl, is the same conditional relative frequency of people that like dogs, given that they're a boy. All right, so let's break this down. Okay. So let's take a look. I'm going to bring in, let's see, I'm going to bring in this table to help me out, even though it's got some wrong data on it. I'll just erase that. Okay. So I'm going to create a conditional relative frequency table just to kind of show what I'm talking about here. Okay. So I want to create conditional relative. First, I have to think about this. What I'm interested in is seeing the distribution of the genders and what pet that they like. Let me just make sure I'm still recording. Okay. So if I'm a student is a girl, the question is, what's the relative frequency of them liking dogs, cats, or others? And does that compare to the boys? So for instance, of the girls, is it that 40% like dogs and 30% like cats and 30% like other? And then for boys, it's the same 40, 30, 30? Or is it that there's a difference? If they're the same, that means that there is no association between gender and what type of pet you like. But if there is a difference, then there will be association. Maybe girls like dogs more, girls like cats more, or boys like other more. Who knows? The question is, how do I figure that out? Well, I do that with conditional relative frequency. So I'm going to take the total for girls, and I'm going to use that as my denominator. I'm going to use it as a given that it's a girl. And then I use my intersections as my numerator. So this is giving me my conditional relative frequency, where the condition is that it's a girl. So out of the girls, what percentage like dogs, what percent like cats, and what percent like other? I'm going to go ahead and do that math, do the division. 45% like dogs, 9 out of 22. 41% like cats, and then 45 plus 41 is 86, so 14% like other. And of course, this is going to be 100%. Okay? 100% of girls are girls. Yes. Okay. 100% of boys are boys. Awesome. Okay. Now, let's do the same thing for boys. In this case now, I've got 38. So 38 boys, that's my condition. Is that a boy? It's a boy. Now, if there's no association, what I should do is I should divide these and I get the same percentage. Okay, so boys that like dogs is 12, boys that like cats is 6, boys that like other is 10. Now I'm going to go ahead and do my division. 10 over 38, 26%. Awesome. Well, there you go. We see that there is an association. Immediately, there's a difference. 6 out of 38, 16% like cats. And 10 out of 38, 26%. Wait a second. Did I do something wrong? 12? How did I do that wrong? 12 out of 26 is not, out of 38 is not, it's 32%. So 32%. I don't know how I did this wrong. 12 out of 38 is 32%. Oh my gosh. This is 28. Oh, poor my soul. I was going to say these numbers are not adding up. Oh man, I have really messed up this whole lesson, but that's okay. It's okay. I hope you guys noticed that I did my math all wrong. I hope you did. I hope you weren't just following me blindly. So this is 28. Yes, Kevin, Mr. Manier. 12 plus 6 is 18 plus 10 is 28. Gosh. Okay. 12 out of 28, 43%. All right, this is making more sense. So that's pretty close. Not bad. 6 out of 28 is 21%. So that's way less. And then 10 out of 28 is 36%. Okay, so clearly we see there's an association because they are not the same. Okay, they're not the same. All right. Now, you might be like, well, wait, 45 plus 43 don't add up to this total. And yes, you would be completely correct. 45 plus 43 don't add up to this total. And the reason why is because I am not doing the conditional relative frequency for the columns. I'm doing it for the rows. So this is a condition for the row. So these will add up to 100%, but the columns won't add up to 100%. If I did it the other way around, 10 over 22 and 12 over 22, then it would have added up. But see, I'm doing 10 over 22 and 12 out of 28. So they're not going to add up to 100% for the columns. Okay, so let's compare. These are pretty similar. Almost margin of error. I wouldn't say there's much difference. It's just about as likely that you'll like a dog, whether you're a girl or a boy. But these are significantly different. These ones are significantly different. If you are a girl, you're about twice as likely, 41%, to like cats than for boys. So boys, the percentage of boys that like cats is about half of the percentage of those that like cats that are girls. And then also this is significantly different. Almost, again, 250% probably. More than twice as likely, if you're a boy, it's more than twice as likely that you'll like other pets than if you're a girl. And you can probably imagine it's probably snakes or lizards or turtles or something like that, crazy boys with their crazy reptiles or something. I don't know. But the point is that there is clearly an association. Is there association for dogs? No, not really. It's about just as likely for a girl or for boys that you like dogs. But for cats, there's clearly an association. If you're a girl, you're more likely to like cats. And for other, there's clearly an association. If you're a boy, you're much more likely to like another type of pet. And there you have it. So this is using conditional relative frequency to determine whether or not there's associations. Okay, and so this is the kind of thing that is real life stuff right here. We want to be able to make determinations about data. If I was someone that owned a pet store and I had this data, well, in my section of dogs and cats and others, I would market it differently. For instance, for dogs, I would make it like basically neutral. It wouldn't be marketed towards boys or girls. It would be marketed towards both, or just simple stuff, just talking about dogs. For cats, I would probably be more likely to market it towards girls. Maybe make it pink and fluffy. I don't know. Just something that girls like. Sure. You'd market it. You'd market the cat section for girls, and then for the others, you'd do marketing towards boys. You'd put things that boys like in the same section as your other pets. And so you see, when we're looking at this data, we're seeing that using these conditional relative frequencies and determining these associations can actually help us to make choices. And that's how this really applies to the real world. It's not just, can I use a two-way frequency table? Do I know how to manipulate the data and get answers to questions? The question is, if I have a set of data, can I use that data and analyze that data in a good way to make appropriate decisions? If this was my data and I was the owner of a pet store and I put a bunch of I don't know, random girl oriented marketing stuff in my section for other pets, that's actually not targeting my market. My market for other pets is actually mostly boys. And the same thing for cats. If I was a store owner and I marketed all to boys, well, I'd be missing out on the bigger part of my market, which is girls. So we don't want to just think about math as just this way to answer questions in a math textbook or on a test. We want to realize that mathematics is a tool that we can use to make decisions. And mathematics helps us to make informed decisions and helps us in the long run to be successful in whatever we're doing. And this is a perfect example of that. Okay, so with that being said, this video is clearly long enough. And I've reached the end of the lesson, 41 minutes long. This is your homework. I think that I've been thorough enough that you should be able to answer all the questions. Go back, look through this video, and give it a watch to get answers if you get stuck. All right, this has been a long one. I said it was going to be a little harder, but with this, you have now finished your last pre-algebra curricular math lesson. So stay tuned, because coming up after this will be extracurricular preemptive strike in the heart of algebra. Love you guys. Till next time, enjoy mathematics.